Welcome back to the channel. Today we are diving into one of the important transformations happening in cybersecurity right now on how artificial intelligence is reshaping zero trust architecture. Zero trust has always been about never trust, always verify. But with cloud adoption, remote work, and sophisticated identity-based attacks, traditional zero trust controls are no longer enough. In this video, I'll walk you through how AI enhances continuous authentication, adaptive access, automated detection, automated response, and identity governance. Let's get started. Zero Trust plus AI. Why this matters now. In our first section, we explore why AI has become essential for zero trust. Traditional zero trust relies heavily on static rules and periodic reviews. But attackers today move fast using compromised identities, lateral movement, and stealthy techniques that bypass static controls. AI changes the game by introducing behavioral analytics, dynamic risk scoring, automated policy enforcement, and real-time detection at scale. This is where zero trust becomes living, adaptive, and context-aware. AI-driven continuous authentication. In this second section, we'll look at continuous authentication powered by behavioral biometrics. AI models analyze keystroke dynamics, mouse and touch interactions, device handling, even gait and motion patterns. These signals are extremely hard to fake. AI learns your behavioral baseline and detects deviations instantly. If something feels off, like a sudden change in typing rhythm, the system can trigger step-up authentication or terminate the session. This gives us identity assurance without user friction. UEBA and anomaly detection. Section 3 focuses on User and Entity Behavior Analytics or UEBA. AI aggregates telemetry from authentication logs, network traffic, endpoints, cloud APIs, and more. It builds behavioral baselines and flags anomalies that humans would never notice. Techniques like isolation forest, autoencoders, and LSTM models detect subtle deviations. UEBA becomes the behavioral nervous system of zero trust. Adaptive access control and dynamic risk scoring. In this fourth section, we explore how AI enables adaptive access. Instead of static RBAC, AI evaluates contextual signals in real time. Device posture, location, time of access, behavioral anomalies. Each request gets a dynamic risk score. Low-risk users get seamless access. High-risk scenarios trigger MFA, restrictions, or denial. This is zero trust that adapts to the moment. AI-driven policy enforcement with policy as code. Section 5 covers AI-driven policy enforcement. Using frameworks like Open Policy Agent, organizations codify access rules as machine-readable policies. AI enhances these policies by feeding risk scores, behavioral anomalies, and compliance signals into the decision engine. Policy enforcement points apply decisions instantly across cloud, on-prem, and hybrid environments. This gives us consistent, auditable, scalable enforcement. AI plus SIEM/SOAR/XDR for automated response. In this sixth section, we see how AI transforms detection and response. AI correlates logs, alerts, and behavioral data to identify complex attack chains, privilege escalation, lateral movement, insider threats. SOAR platforms then execute automated playbooks, isolate devices, revoke access, terminate sessions, notify analysts. AI reduces mean time to respond by 40 to 70%. In some frameworks like ZenGuard, response time drops to under 15 seconds. AI techniques behind Zero Trust. Section 7 breaks down the AI models powering Zero Trust. These include isolation forest for anomaly detection, autoencoders for behavioral reconstruction, LSTM for sequential anomalies, clustering for peer group analysis, reinforcement learning for policy optimization, graph neural networks for attack path modeling. Each model plays a specific role in strengthening identity, access, and detection. Identity lifecycle and entitlement management. In this 8th section, we explore how AI automates identity lifecycle management. AI detects role changes, unused entitlements, and suspicious account activity. It triggers automated provisioning, deprovisioning, and access cleanup. It also prioritizes entitlement reviews based on the risk and usage patterns. This reduces privilege creep and strengthens least privilege enforcement. Multi-cloud identity and federation challenges. Section 9 focuses on hybrid and multi-cloud identity. Different clouds use different token formats, session rules, and access models. This creates fragmentation. AI solves this by correlating identities across providers, detecting anomalies, and enforcing consistent policies. Federated learning even allows cross-cloud threat detection without sharing raw data. Device posture attestation with AI. In this 10th section, we look at device trust. AI evaluates device posture continuously. Operating system version, patch level, and encryption status. If posture degrades, access is restricted or revoked instantly. Platforms like Cloudflare One, Citrix Device Posture, and Microsoft Entra integrate these signals into Zero Trust policies. AI agents as first-class identities. Our final section explores a new frontier: AI agents as identities. As autonomous agents perform tasks, they need their own identities, tokens, permissions, and audit trails. Zero Trust applies to agents exactly like humans. Authenticate, authorize, log every action, enforce least privilege. Solutions like Microsoft Entra Agent ID make this possible at scale. And that wraps up our journey into how AI is transforming Zero Trust architecture. Thanks for watching, and I'll see you in the next one.